Welcome to Mastering Mathematics. Here's our instructor, Dr. Karen Weston.
Hello everyone, welcome again to another in the series Mastering Mathematics. This is a program sponsored by the Ministry of Education using its EBU unit, Center for Mathematics Education, and ABS Television. I am Dr. Karen Weston, and with me is Jetta, and together we are going to make certain that you enjoy what we are trying to do in terms of making certain that you're confident going into your mathematics examination. And then for those of us who are following on at home, that you are seeing that age is just a number, and that at any stage of your life you can learn new facts and new information. And the grandchildren are testing themselves too to say, we can do these things. So it's not a matter of what class you're in, all right? We start to say that we are actually categorizing and saying you're in first form, second form. Anybody can learn anything at any time, all right? Where there's a mind and with God in the vessel, everything is possible. Now, yesterday we gave you the first of the section A from the CSEC January 2015, the number 6 question. The diagram is still here, and we know that it's a diagram. This is a diagram. It is not drawn to scale, and we're asked to do certain things, all right? So what do we have to do now? The first thing we had to do was to measure and state the length of PQ on the draw-in. And we did that, and we got that it was equal to 3.5 centimeters. Now, we are now being asked to say, so what scale did they use to do this drawing? Yes, question still etched on our brains. What is the scale of the drawing? Remember that we were asked to measure and state the length. Measure does not mean calculate. You understand? You're using your rule from your geometry set, which may be just as short as this. Put it against right here, okay? And we are measuring, and you can see, cameraman, we zoomed right in, that it would be equal to 3.5 centimeters. That is all you have to do. Don't go and say you're calculating and doing all sorts of things. They ask you just to measure. Measure means using your ruler, and you just do it and you read off the measurement. And that is how we got our 3.5 centimeters. But now they're asking us to say, so what scale did the examiners use to get this drawing on the side if it is representing the side of a building? Because we are seeing 18 meters and 9 meters. So how do you think we're going to find the scale? Chet, what do you think we'd have to do to find the scale here?
Have to divide it by the...
So our first task would be again to measure using our ruler the length of the side on the picture. All right? Because they could have written that this is 500 meters, you know, but they're drawing it. So what do we know from having done this using our rule? We can see that when we measure it on here, that it is the 18 meters, which we have translated to be 1800 centimeters on the diagram, is really equal to 6 centimeters. And we can see this right away, all right? Because we're using our ruler right here to measure it. And we see, so that we know that, so there is a correlation that says 1800 centimeters is really equal to 6 centimeters on our diagram. All right? So we want to know what would 1 centimeter represent. And so again, from 6 centimeters is equal to 1800 centimeters. So we want to find 1. And we're dividing both sides by 6. Isn't that true? Okay. Because we want to find the scale. And when we do that, we see 1 centimeter would be equal to our 300 centimeter. So that the scale on the graph would be 1 to 300. And that's what we do. Okay? If you didn't use the 1800 and you used the 900, you would actually get the same answer too. Because when we do that and we measure, okay, we use our rule again and we are measuring on the diagram, we see that the 900 centimeters is equal to 3 centimeters. You see that, Jetta? All right, measure, not calculate, measure 3 centimeters. All right, so you could have used that side too and getting and saying, oh, this one is actually going, so the blue is coming up. 900 centimeters is really equal to 3 centimeters on the diagram. And we want to find out what is 1 centimeter, dividing both sides by 3. 900 divided by 3. Okay, the centimeters would have cancelled. You're getting your 300 is equal to your 1. So again, the scale would have been a 1 to 300. Right? Yes. So that is what question the part 2 of this question was asking. And then we have, and 2 marks for that, 1 mark for stating the first one, obviously, so you know it's nothing too big that you had to do. And then we now have to calculate the actual area. Calculate the actual area of the face. This is what is called the face, all right? The face of the LMNPK on the diagram. Calculate the area of the face LMNPK on the diagram. And I know some smart grade 6 students say, I know how to do that, I know how to do that. Because yes, your teachers would have been telling you these things, isn't it? If we had a scissors and we had to cut off these things, what are we actually finding the area of? When they ask us to find the area of LMNPK. Jetta, can you tell me?
Rectangle and a triangle.
Rectangle and a triangle. It doesn't matter how complicated the figure looks. I told you already, every last one can be broken down into single figures and shapes. And so what we're dealing with is, can you follow me? This is a rectangle. And when we see this sign in here, we know we have a right angle. Isn't that true? So this is a perpendicular. And they told us that Q was the midpoint of this. So KN would have been the base of that triangle. So we're dealing with a triangle which we can call KPN, and we're dealing with a rectangle which we can call LMNK. Isn't that true? So we have to find the areas of those 2 figures. And what would we do? We would add the 2 areas, and that would be the total surface area of that. You want to try it. You don't want me to tell you, right? So again, I'm sending you to have your little rest and whatever your break from this classroom. We will be right back to that. You're going to say, yes, Miss Weston, although you told me to go on a break. And don't call me no Miss Weston. You have to say what? What do they have to say, Jetta? Dr. Weston, as my supervisor, will do what? Have their necks. Okay, but that is just child's play, all right? Because what we're doing now is saying, thank you very much, Nottingham, but we're using the information to make our lives better in this country. So don't worry, think, yes, no, it's not the doctor that we're talking about. We're talking about the information, and we're going to be using that. But yes, so Jet and I will send you on a break, take you a little break, because we're having fun here, and you better have fun, because this is what mathematics is, a lot of fun. Okay, so all these things you see these contractors saying, boy, I thought building a building was so hard. Did you see these beautiful buildings that they told us in the parliament that these people constructed? Yes, that is what I want to. I want some more students coming up and doing their own architectural designs. So see you in a minute. Go and drink some cold water and come back again. Drink some water. It does something to the soul.
understand I didn't, but I can hear and feel it. I still.
I may not hear, but that does not and should not affect my ability to learn and to function in the real world.
I am a gifted student. I need the opportunity to soar. Support me in my climb to higher levels of learning.
Some of our children have special educational needs. They have a right to an education. So, let us teach them the way that they learn and help them to achieve their full potential.
To succeed in mathematics, you need to build on what you've learned before. New concepts are added to and build upon previous concepts. It is very important that the early material be mastered thoroughly. Similarly, mastery of material from previous classes makes success in later classes more likely. So continually review and practice concepts from previous sessions.
Carefully read over the sections of your textbook assigned by your teacher and look carefully at the sample problems. Decide if you benefit more by reading before or after the instructor covers the material.
Join us for a new series of Mastering Mathematics, Mondays and Tuesdays, 6:30 p.m. here on ABS TV.
All right, so yes, you've had your fun. We have done everything. And notice how slowly I'm going, so my friends don't meet me on the road as I'm supposed to remember me so fast. No, we're taking our time because we want it to be a learning experience too for our students. You'll never ever forget it, okay? So yes, there's no rush deal. We want you to make certain that you understand what is, okay? CSEC had started, and what are we picking up? There's a difference in meaning between the word calculate and measure. Because I know a lot of you have said, I thought I had to use Pythagoras' theorem to find the length of PQ. No, they said measure. And what does measure means? Use your ruler, all right? And you slash it against here and you measure it. We've shown you how you would have found your scale. Okay, this is saying 18 meters. We translate to centimeters. So you're saying that this should be really being 1800 centimeters. And when we measure it using our ruler, we're getting that it is 6 centimeters. So the measurement of 6 centimeters on the diagram would really represent 1800 centimeters. So then we do that, our conversion, to say what would 1 centimeter represent, and that's how we got our scale for our map. Now they're asking us to calculate the actual area of the face LMN PK on the building. And we have said that it represents, this face represents the figure of a right angle triangle and a rectangle. And if we take them apart, we would know that the base of this right angle triangle is the same length as this side, because a rectangle, the opposite sides are also equal. All right? So that this then, for our triangle, it would have been, the base here would have been 1800 centimeters. And because it's a right angle triangle, we can say area of triangle, and look on the front of the paper because the formulas are there. It would be equal to half the base times the height. And do we have the information? Yes, we do. PQ would have given us the height of the triangle, all right? So then we know it's equal to a half times 1800, and it's times the height, which I said I got as 3.5. all right? And when we do our calculation, you can put that in your calculators, and right away you're going to see that this would have been equal to 10.5, and its area, so it is centimeters squared. Do not forget to put your units, okay? After that, we are left, and what do we have? The rectangle. And we know again that the area of the rectangle, that would just be equal to length times width. And that is just equal to your 1800, and it is times your 900. Okay? And when we do that, we are going to get that it is 162, so that it is now equal to 162,000 cm squared. So that the total, calculate the area of the face, the total area when we join the two together would be equal to 162,000 cm squared plus, okay, and it would be our 10.5 cm squared. And we see how we get our answer. It would be 0010.5 cm squared. And that's it. All right? And that is it. So, notice what we had to do. And in an examination room, you'll be going quickly. But you see, we are showing you the things. What do I need to solve a question like that? What do I need to solve a question like that? And if you think that that was really easy, look at this one again, the B part to it. This is where you're going to come back next week, and we're going to do this one, okay? This is what we're going to do, because it says the diagram below, not drawn to scale, shows the plan of a swimming pool in the shape of a rectangle and two semicircles. The rectangle has dimensions 8 meters by 3.5 meters. And they're asking us to state the length of the diameter of the semicircle AFE, and also after that to calculate the perimeter of the swimming pool. Right? You understand? 2 semicircles, okay? And then we just have to state, and they've given us that the rectangle, that the width and the measurement for that would be an 8 meter by 3.5 meters. And then attached to that, to complete the swimming pool, we have 2 semicircles, so the deep end and the shallow end. All right? And then we have to find the perimeter for that. We're not going to have enough time because you know we're not going to rush everything. But again, I know my grade 6 students can say, so what are the 2 shapes we're looking at here? Jetta, do we know? What are the 2 shapes we're looking at here in terms of this swimming pool?
Semicircle, 2 semicircle, and a rectangle, or circle and rectangle.
Exactly, because 2 semicircles would give us a circle and we have the rectangle. No, they have given us, look at how they have done it here. They have given the drawing here. You can see your 3.5 meters, okay? And we're not stupid. Don't you see the arrow telling you the dimension? So we just have to know the paths of a circle. Isn't that true? Yes. And the diameter is?
3.5.
It's just 3.5. You read it right away. CSEC is just giving you marks, man. Okay? You don't have to do any calculation here. The diameter here would be 3.5. And how would we find the perimeter? The perimeter means we are walking the boundary. Isn't that true? Right? So even if you're starting from here, going here, 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 run your little dog along here, 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 here. Even if you're starting from here, you're going all the way. Not inside, but outside. Isn't that true? So really, we are interested with the circumference of a circle and the two, and we're interested with the length of the rectangle. Can it be any simpler? Right? We can finish this right away. Isn't that true? Okay? But we want you to try first without rushing to give you the answers, and then to have you competing with us here to see if you got it right. So this next week, you're going to be faced, yes, because I'm doing the work, because I want these things to look neat and nice when we put them on the board again. So this is what you have. And next week, this is where we're going to start. Draw a rectangle, draw 2 semicircles, see where the arrows are, and you see that the distance between the semicircle, the width of the rectangle would be 3.5, okay? The length is 8 meters, 3.5 meters, 8 meters, 2 semicircles on each end, and they're asking, the 2 questions you're being asked is, what is the length of the diameter? And then after that, they're asking you to find the perimeter of this swimming pool, they call it, but of this figure here. So test your wit against us right here in the studio and see if you're going to get the right answer. So we give you a chance. So we're not going to give you the answer this time, but we know it's already on our tongues. And then I'm going to bring back some more figures again to show you, another figure again to show you next week, which will be the question 8. And you're going to see, oh my gosh, man, these people have fun when you get in the examination room. What are you talking about? Okay, somebody fooling us and telling us that we can't do mathematics. Just tell them they're not Antiguans if they say that, because we know we can. All right, so this again, we're signing off, we're sending you. Enjoy what we have done. Give yourself some little practice. Although we did this question, you give yourself little numbers. Keep working it, because that is how you're going to get good. And remember, there is a difference between CSEC asking you to find the measurement and asking you to calculate. So when they ask you to find the height, measure, okay, we're just using our ruler. If they ask you to calculate, you'd have to get into Pythagoras' theorem. They didn't ask you that. Okay, so don't look for difficult things. So the 2 words you have to know the difference between is measure and calculate. So just look at what 6 is asking and do the particular thing. Yes, we're going to send you into that examination room well prepared. Remember our website, masterinmathematics.info. You can go and see the past papers there too. So you can go and leave through and say, let me see if I have any more questions like this. Let me try them for myself. Then you can meet me and say, Miss Weston, on 2005, they had a question like that and I did it. And I will say, okay, let's check and see if you got your correct solution. And just now we are working on the solution for the other questions. They will come too. And of course, I forgot to work with that tablet. Remember, everything is on YouTube and Facebook, so that you can go see me right there teaching, and you don't have to be in a classroom. You can just take a nice little cool walk anywhere for yourself, under a grape tree, on the beach, any old place, and learn the mathematics. Okay, you don't want to be sitting home for 2 years because you don't have mathematics, and it's something you can have. That is what burns, because but if I did an exam, I would do it, I could pass it, and we are making certain. And of course we have to thank Family Dentistry, because my Barbudans, I know you're listening too. I'll be over on Saturday and we'll be continuing the task, because we are going to pass the mathematics, and we can't thank that good citizen enough, the Family Dentistry and its corporate and its members, of how they're actually making certain that Barbuda is on board. So until next week, this is Dr. Karen Weston saying, do enjoy the rest of what's left of your day.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.